All right, people, as promised, here's your video for the rest of the notes. There are two problems left, and we're going to dive right into it now. And so whatever I write, you write. That's just what we do. That's just the norm. So if I write it, you write it. That's what we do. Okay, let's go. Suppose you have $20 in your bank account. You start saving $5 each week. Your friend has $5 in his bank account and is saving $10 each week. Assume neither of you make any withdrawals. Write an equation in slope-intercept form that models the situation. Define what x and y represent in this situation. Okay, so we know how to define x and y. We look for the rate of change, and the rate of change will tell us what our x and our y is. So the rate of change, we look for words each connected to a number. We look for every, per, something like that shows that some number is changing over a certain amount of time. All right, you start saving $5 each week, so that's my rate of change, $10 each week. And so we know it's change in y over change in x. Okay, y'all have been having so much trouble with my pens, and this is now writing so beautifully, yay. All right, so we know that our x is our independent variable, our y is our dependent variable. So we know y depends on x. So in this situation, money will depend on the weeks or time. So x, change in y, $5, dollars is our y, and then weeks is our x. Please don't get used to thinking that, oh, it goes in order, x, weeks, x, dollars. No, that's not how we do it. This is y, and that's x. All right, so now let's write an equation. It says, suppose you, so we have u, the u equation. Have $20 in your account and you start saving $5 each week. Okay, this is pretty simple. Y is equal to 5x plus 20. Your friend has $5 in the account and saving $10 each week. So they have $5 in the account, initial value, starting value, and then y intercept, and they save $10 each week. So 10x plus 5. All right, those are our equations. Now it says create a table that represents the total money you save. Now notice this table is smaller, so this is what's going to be on your test tables like this. So we have y, this is the u equation, so we're going to use y equals 5x plus 20 to build our table here. And then over here, we're going to use y is equal to 10x plus 5. All right, so we're going to use the x values, which is our input. This is our output. Put in 0, 1, 2, and 3. That's where we always start. So when I put 0 in here, it goes here, it goes there. I get 5 times 0, which is 0, plus 20 is 20. 5 times 1 is 5, plus 20 is 25. 5 times 2 is 10, plus 20 is 30. 5 times 3 is 15, plus 20 is 35. So we should see, y'all, this is the initial value. This is the start. And then the rate of change is going up 5 every time. So we should see going up 5 every time. That's the slope, 5 over 1. We should see that in the problem, okay? That's where the slope comes from. That's where the rate of change comes from. Change in y over the change in x. Okay, here we're going to use the same input value, 0, 1, 2, 3. And so when I put in 0, I get 5 output. I put in 1, I get 15 as the output. Put in 2, I get 25 as the output. Put in 3, I get 35, because 3 times 10 is 30, plus 5 is 35. So I should start at 5, and then I go up 10 every time. 10 over 1, over 1, 10 over 1. All right, have we found our solution? Yes. And what is this, everybody? Where the two lines intersect. Okay, so we don't need to keep going. All right. That's not what I want. Let's bring you down over here. So it says plot the graph of each table on the coordinate plane. So our first equation, let's go back up here, 5x plus 20, and then 10x plus 5. 5x plus 20, and then 10x plus 5. So y is equal to 5x plus 20. And then this is 10, y is equal to 10x plus 5. Let's label our x and y axis. Our y axis was dollars. Our x axis was weeks. And so this is where I said go up by 5s, because there's only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we can't start at 20, y'all. So we're going to have to go up by 5s. This is increasing by 5s. This is increasing by 10s. And both are divisible by 5. 5 is divisible by 5. 10 is divisible by 5. So we're going to go up by 5. So this is going to be 5. And this is 10. This is 15. This is 20. This is 25. The only reason why I'm skipping numbers like this because I don't want to get everything congested right there. 25. This is 30. This is 35. This is 40. This is 45. Okay. All right. We get the point. So this line starts at 20. This is 5, 10, 15, 20. This line starts here. And it goes up 5 each time. And this is 1, 2, 3. So we can just see that. Maybe I could write them in real small there. 5, 5, not 1, 2, 3, 4, 5. That's 25. 5 over 1 is here. 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 5 over 1. That's where that's at. That's where that's at. All right, pick another color for the other line. Well, let's draw the line. So we get the line in here. Right, we get the point. All right. And now we're going to graph the other equation. This says start at 5 and go up 10. This is not 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 50. Come on, y'all. So I'm going to go up 5, 10 over 1. 10 over 1. 10 over 1. 10 over 1. Now draw my line. Okay, so it says, where do the graphs intersect? Or where do the graphs of each of the savings intersect? Well, they intersect at 335. Y'all don't make up new numbers. We found this already. You know what I'm saying? If you just wanted to go through and do this all before you even start the next section down here, you want to come up here and just finish this, we found it. It's right there. That's where it's in the table. It's right here in the graph. That's where they intersect. What does this point represent? Okay, well, this represents my x. My x is weeks. Remember, if I write it, you write it. This represents my dollars. This is my y. So at 3 weeks, both me and my friend will have $35. Excuse the handwriting. What is the relationship between the number of weeks? Sorry, what is the relationship between the point of intersection and the equation for you and your friend's saving? Okay, so the relationship is at 335. I kind of phrased this wrong. I don't want to say at 335. I want to say something else. Maybe the point 335. The point or the pair 335 makes a true statement for both equations. All right, so let's do this. I want you to see this. So we're going to come back up here and work this. I'm sorry, I keep doing this wrong. So at 335. So when I input 3 here, so I'm going to kind of put the y on the other side. So, well, never mind. Just leave it like this. So we're saying that 35, because that's my output. My output is equal to 5 times 3 plus 20. Let's see if that's true. 35 is equal to 5 times 3 is 15 plus 20. Well, 15 plus 20 is 35. That's a true statement. When we get to equations, we're going to see it all over again. It's like checking your equation. So we're saying that 35, My output is equal to 10 times my input plus 5. So 35 is equal to 30 plus 5. 35 is equal to 35. Yes, this is going to really let me know. I'm going to tell you a secret. This is what I'm going to really be looking for when I look at your notes. So just tell y'all that little secret, Because some people are not going to write that, but I know you are. Okay, the temperature in Syracuse, New York, started at negative 14 degrees Celsius and rose 2 degrees every hour. The temperature in Mamaroneck, New York, started at negative 2 degrees and rose 1 degree every 2 hours. All right. Write an equation, slope-intercept form, the model situation, define x and y. This should be a breeze, y'all. We should just fly through this. Define x and y in the situation. So, defining x and y. X, Y. Look for the rate of change. The rate of change is 2 degrees every hour. 1 degree every 2 hours. So degrees is my Y, and then hour is my X. So hour, and then degrees. So we have Syracuse. I don't know why it's hard for me to say that word. And then we have, I don't know what this is. I'm just sounding this out. Mamaroneck. All right, so Syracuse started off at negative 14 and rose 2 degrees. So we know the rate of change is 2x. Started initial value, and we said Mamaroneck started at negative 2 and rose 1 degree. Rose. Everything is rising. What if it fell? What would happen? It would be negative. So rose 1 degree every 2 hours, and it started at negative 2 degrees. So we have the Syracuse equation over here. That's going to build our table. And then we have the Mamaroneck. That's a mess. Whew, goodness. Work on that handwriting, Mr. O'Neill. All right. So let's look at here. So input 0, 1, 2, 3. 0, 1, 2, 3 to start us off. So I put in 0, I get negative 14. I put in 1, I put in 1. I get 2 times 1 is 2, minus 14 is negative 12. I put in 2, that's 4, minus 14 is negative 10. Now, what am I doing every time? I'm adding 2. So let's go ahead and take the shortcut, y'all. We're adding 2 each time. We know that. We start here, and then we add 2 each time. So I add 2 to U, and that's negative 8. Okay, so I put in 0, I get negative 1/2. I get negative 2. Put in 1, I'm taking 1/2. I'm taking 1/2 and I'm subtracting 2, so that leaves me at negative 1.5. I put in 2, half of 2 is 1. 1 minus 2 is negative 1. What am I doing each time, y'all? I'm starting in negative 2 and I'm adding on 1/2. What's negative 1 plus 1/2? You get negative 1/2. Look, y'all, they have not intersected yet. So what do we got to do? We got to keep going. So we got to go to 4, 5, 6. Try 3 more. Over here, we're adding 2 each time. So we got negative 6. We get negative 4. And we get negative 2. Over here, we're adding 1/2 each time. 4, 5, 6. Add 1/2 here, you get 0. Add 1/2 here, you get 1/2. Add 1/2 here, you're at 1. Goodness gracious, they still haven't intersected. We're in the positives over here. We're still in the negatives. So that they won't intersect until these get into the positives. So at 7, we add 2, we get 0. And at 8, we add 2, and we get 2. All right, so at 7 here, we add 1/2 and get 1.5, and at 8 here, we add 1/2 and we get 2. Well, will you look at here? Will you look at here? It took us 8 times to find the intersection. All right, and what is this? The place where both lines intersect. All right, let's go. Let's do it. Let's finish it. Let's be done. All right, because this video is already 14 minutes long. Now, some of y'all was mad when you looked at the time. Too bad. Get over your life. That's what excellence calls for. Don't let me start. All right, I'm gonna let it go. Let it go. Let it go. All right, where did the graphs of each city intersect? Well, we need to put the equations. So we have y. I don't forgot the equations, y'all. I got to scroll back up and see. How could you forget, Mr. O'Neil? I just, too much of them. I let it go. Oh, my. So y is equal to 2x minus 14. And then the other equation was y is equal to 1/2 x minus 2. Wasn't that it? Yeah, that was it. All right, so this, whoa, I got to start all the way down here at negative 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Let me count that again because I don't want to start this video over. 1, if I mess up, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'm right. And slope is 2 over 1, up 2 over 1. Up 2 over 1, up 2 over 1, up 2 over, we got to go for a while. They don't even cross until they get into the positive realm. Up 2 over 1, up 2 over 1, up 2 over 1. I know that's where they cross because it should be, yeah. All right, draw the line. Okay, and then we have our other line. Start at -2 and going up 1 over 2. 1 over 2, 1 over 2, 1 over 2, 1 over 2. We got it, y'all. We about to be done. Oh, we about to be done. Hey, where do the graphs of each city intersect? They intersect at 8, 2. We found it already. What does this intersection represent? Oh, y'all, we forgot the label. What's wrong with y'all? This is degrees. And this is, what was the other thing? I'll scroll up and see. Hours. So at 8 hours, 2 degrees. I don't know what I was spelling. I'm hearing grease in my head. I was starting off with grease. At 8 hours, be 2 degrees. What does the intersection represent? At 8 hours, both cities will be 2 degrees. What is this relationship between the point of intersection and the equation for the city's temperature? The point 82 makes a true statement for both equations. Y'all know what I'm about to do? Show you. You know why? Because some people are not going to have it. And they're going to be like, but why get a 50? I did all this. I said, watch the video and do everything I said. All right. So are you telling me that when y is 2, 2 times 8 minus 14, 2, the output is equal to 2 times the input minus 14. Let's see this. 2 is equal to 2 times 18. 8 is 16. Minus 4, I had it in my head and just blurted out my mouth. 16 minus 4 is 2. You're right. It works. It works. It works. All right, so y equals 2. Are you telling me that the output is equal to half of the input minus 2? Well, let's see that. Half of 8 is 4. And 4 minus 2 is 2. Is that what you're telling me? That's what you're telling me. Okay, so you've been amazing. And if you really watch this video, I'm going to say somewhere in the video, I made up a word. Yep, I made up a word, my own little word. And if you remember that word is going to give you 2 extra points on your test tomorrow. If you remember the word that I started to misspell and you spell it the way I was going to spell it, you get 2 points on your test tomorrow. This is Mr. O'Neil. This has been another Beast Mode production. Y'all like my new Beast Mode production. And I'm gone. Have a great. Oh, I forgot. Put the word at the top of the paper. So in parentheses after your name, put the word that I was going to say. Okay, now I'm out for real. Bye.